picture is not pretty. We are suffering losses at genetic species, population, ecosystem levels, and we are reaching a tipping point in our ecosystems caused by climate change, land use practices and invasive species in relation to Banksia woodland. At this particular moment in time, I think it is one of the most critical turning points we have been in along the timeline of white man's impacts on biodiversity in Western Australia. I think we're almost reaching the point where there may be no going back. And I guess throughout this journey along the world of weeds and biodiversity and Banksia woodland, part of my method of how do you keep going is keep devising new ways to try and get the people who make decisions to change what they do. And I think we're at another one of those points right now. Also, let's step back to the bigger picture. One of the ways that the international world is saying we should look at the drivers of biodiversity loss, which is what we're talking about with Banksia woodland, is we should be looking at an integrated manner and looking at the whole system, and not just, well, certainly we have to look at individual parts, but we should be looking at the whole system and what the whole system and how it is reacting. That is an ecosystem approach. And I think if we start to look at things in terms of ecosystems, which should then be translated into research, policy and management, we need to direct the research, policy and management in the right direction. This is a case study about Bulb Park. A lot of years of work, but when it really got summarised, the question was, what impacts have fire and invasion had on the Banksia woodland in Bulb Park and other urban reserves? It needed a little bit of working out about fire. We didn't have any recorded history of fire, and I wanted to look at an ecosystem, looking at lots of things happening within the ecosystem. And so this study was looking at all of the things you see at the top in different vegetation conditions, in good condition, medium condition, heavily invaded by veld grass and heavily invaded by pelargonium. It had to be done from aerial photography. So if you look at the amount of green, which is the amount of canopy in 1963, and you look at 2000 and you look at the amount of green, there has been a significant decline in the amount of canopy cover within Bulb Park. And I think that is extremely important in terms of other threats to the system. Once you open a system up and you remove some of the canopy, many of these other things that are happening, such as invasion, such as weeds, love that different environment, and many of those native species also are adapted to having some sort of a canopy. So you're opening up the system. So here we're saying this is very much related to the frequency of fire, the loss of canopy. In the areas across those last pictures you saw, when there were more than 4 fire events, there was a significant reduction in native canopy. It is showing that the relationship between the frequency of fire and the Banksia woodland has changed the canopy. So once you change the canopy, what starts to happen? You have more light. Everything's getting out of balance. Everything's opening up, whereas before it used to be closed. And you've lost a lot of shade. In this picture you see some very old chewits which will have died during one of those fires. And if you look at this very open area, that's the area that would have been under shade from the canopy of the tree, a very highly invaded area. So that's a little story about what fire's done to the canopy. Now let's get down onto the ground and see what's happened to the vegetation in relation to that fire. What was interesting when I had a look at the sites and looked at the relationship to fire is all the ones that were in good condition had only experienced 2 fires between 1963 and 2000. Those in medium condition had experienced 4, and those invaded by 2 different species had both experienced 6 fires. There's a very strong relationship here to the frequency of fire and invasion. And let's see what else happened once we have invasion. Black is the amount of cover of native species, and the grey is the amount of cover of introduced species. There is a significant reduction in the amount of cover of native species, both between good condition and medium, and then between medium and invaded areas. And there's also a very high level of introduced species. What does this mean? Just look at the circles. The life forms of the native species are very, very different to the life forms of the introduced species. All you need to do is just look at the differences in shading and hatching. Many of these species on this side are short-lived, quickly growing grasses and other species like that, species which don't normally exist in this environment. So the life form underneath in those very open areas is completely changing. These are much more competitive life forms, produce large amounts of seed, reproduce very, very quickly. They don't need many, many years to reproduce. What we have found then in terms of the vegetation and the relationship to fire is there's a reduced canopy cover, there's a complete change in the structure and function of the plant assembly, and particularly the things that are going, these native resprouter species, all the sedges. These are the things that are being lost and probably very critical, very, very critical part of the ecosystem. This is associated with the frequency of fire. So let's have a look at what happened underneath the soil, the seeds in the soil. Once again, just look at the grey, black being native. Once you get into invaded areas and mediumly invaded areas, huge seed load, we're up to 5,000 seeds per square metre. But what is really interesting, in this good condition area, there are more native weed seeds than there are native seeds. So you have another fire, another disturbance event go through, and those quickly germinating species are up there and running, ready to take control. So once again, life forms of the seeds in the seed bank, very, very different between the introduced species and the native species. So the consequences are that you have a very different new system waiting to come when the rain comes or whatever the factors are there for germination. Once again, it means you've really got a very compromised potential for that community to recover from disturbance. Nutrients in the soil and the leaves. What was found in this study in the soil, in the good condition sites, had significantly less phosphorus than the soil in the sites that were invaded by veldtgrass and pelargonium. So there's an increase in phosphorus, and we have heard or we know that Banksia species and many of the Banksia woodland species are not tolerant of high levels of phosphorus, so the soil conditions have changed quite dramatically. And this was the same in the leaves of the species. What was found in this study when I looked at the individual native species was that the Alocasuarina species was one of the few native species which actually really took up the extra phosphorus and loved it. And that may be why we're changing from Banksia woodland to Alocasuarina in Kings Park. This study has shown very briefly that we have too much fire, we have invasion, and the whole system starts to change. The whole ecosystem is changing and making it very, very difficult for our Banksia woodland to function. We should place our emphasis on studying the consequences of intervention. But my question is, why isn't anything like this happening across the Banksia woodlands? And I think that's a really important thing. Why aren't we measuring? Why aren't we getting some baseline data on our interventions? And let's make use of this sort of knowledge to actually start making these things happen, prioritise policy and management of invasive species in biodiverse ecosystems. I think at this particularly critical time, unless somebody does these things, we don't have a great future for our Banksia woodlands. We need to provide protection from land use change, protection from fire. I think these results show how really important it is to protect the Banksia woodland from fire, protection from invasion. Why is not the whole Banksia woodland communities protected so that nobody can touch them? And why are they not classified in this way as a high priority ecosystem in urgent need of investment? Are we asking the right questions? Are we asking the right people what the questions are that we should be researching? And where should we go from here?